All right, let's do modularity again. So in the last video, we talked about Jerry Federer's modularity of the mind. Here, we'll talk about another view of modularity. This is a view proposed by the field known as evolutionary psychology, which will be the subject of the next lecture entirely. Evolutionary psychology has a couple of core beliefs, core agreements that evolutionary psychologists accept. The first is that the human mind consists of hundreds or thousands of dedicated modules that are genetically specified. What we mean by modules here, I'm going to clarify in a little bit. It's not quite in the same sort of thing that we meant in Fodor's case. It just means processes. Number two, the information processing function of these modules, these processes, evolved via evolution by natural selection. During the 1.8 million years Homo sapiens were living as hunter-gatherer tribes in the Pleistocene. The Pleistocene is the era that, I guess, the most recent era. Modern humans have been around for about 200,000 years. Our ancestors, Homo erectus, Homo habilis, all of our ancestors were living roughly in hunter-gatherer tribes for a lot longer than that. But even if you only take the past 200,000 years of human evolution, society has only really existed for the past 10,000 years or so. Civilization has only existed very recently. So the idea in evolutionary psychology is you look back at the deeper past. And then the third one is more of a philosophical claim that these modules collectively constitute a universal human nature. So modules here is not what we meant in Fodor's view. Fodor's modules were very informationally encapsulated systems. Here, they're going to be much more general. This is information processing psychological adaptations. Adaptations I'll clarify in the next video, but that's essentially what happens after evolution by natural selection. The idea is perception is a module, sure, along with Fodor, but so is cheater detection or any psychological traits that our ancestors would have been selected for through evolution by natural selection. In the view of evolutionary psychology, at least according to some of the people that we'll talk about, Cosmides and Tooby, there is something called massive modularity. So the overall organization of the mind is these specialized modules, these processes that solve particular problems that are domain specific to particular contexts. And there is no central cognition, no abstract reasoning mechanism, no executive like Fodor. Fodor's view of modularity of the mind requires there to be a central cognition. Evolutionary psychology denies this. There's some examples that we could give. We'll talk about cheater detection in the next video. I'll talk about psychology right now and numerosity right now. But these are all things that have been argued for in the literature. And there's hundreds or thousands. So essentially any traits you expect would be there because of evolutionary history. So there's several arguments for massive modularity. A couple of them are straightforward, right? The first one is there's evidence for particular modules, that is particular ways of reasoning that seem to not be explainable by reason alone or through how minds would be organized by nature alone, by nurture alone, so there must be some biological nature to them. Then there's arguments for specialized deficits, and these are deficits that we've seen from patients that have suffered accidents or had surgeries, and the idea is they have these particular deficits that are not just things in like perception, there's actually also cognitive deficits that are much more subtle, right? So there's patients that cannot recognize the sight of their friends and family, but they can recognize them if they hear them. When they see them, they think of them as like strangers or imposters or aliens. This is Capgras syndrome. And the idea being that that is a weird kind of deficit to have arisen in that particular way, and that should shine the light on there being some sort of process from visual perception through recognition into cognition. And when that is disrupted somehow, that means that these deficits show us that these processes exist. And then finally, arguing against the domain general view. So if there are modules, which we've shown from argument 1, let's say, and you can show them indirectly from argument 2, or from these arguments, and argument 3 works, there's no general processing, no centralized processing, then massive modularity must be the case. It's modules all the way down. One, which will be the subject of a lot of the next lecture, is this idea of cheater detection. These are conditional reasoning that allow us to detect whether we've been fooled by somebody. And you can actually set this up in completely abstract, arbitrary situations. Again, we'll spend quite a bit on the next lecture on this. But for now, there's evidence, or at least some people think that there is strong evidence for that. Another is this idea of Machiavellian intelligence, the basic idea that perhaps the reason we are intelligent is because we need to fool each other. And in order to fool each other, we must know what each other are thinking. In order to know what each other are thinking, we must be able to imagine other people as being distinct from us, and to be able to imagine them thinking about us, which might be the rise of consciousness, and it might be the rise of all sorts of other things. And it would lead to the idea that there might be some genuine social intelligence module, which will come up in a couple of slides. There's evidence even in non-human primates, right? So there's qualitative evidence where you study, in this particular situation, there was a female, I think, chimpanzee, and an alpha and a non-alpha subordinate, and the subordinate goes out of his way to try to sneak around the leader's vision. So the idea being that the non-alpha is particularly aware of the social dynamics going on and hides his grooming, his basically cheating from the person that can enforce the creature that can enforce the social structure. Humans, you might be surprised to know, or might not, have the largest brain to body size ratio in the animal kingdom. And the idea in evolutionary psychology is that there's plenty of space, plenty of time for this to have developed, and possibly some psychological reasons might be the cause of this. Some social group dynamic reasons might be the cause of this high brain size. Okay, there's other evidence for other kinds of modules. One is this idea that there might be distinct ways of processing quantities. And this isn't just some haphazard thinking. There's experimental evidence I'll show in a little bit. The basic idea is that there's actually multiple ways of representing numbers. One represents specific magnitudes, and the other approximates. And so we might label these the subitizing system, which tracks small numbers, and the approximate number sense, which tracks larger numbers. You, for example, can tell the difference between $2 and $3, but you probably couldn't tell the difference between a pile of $1 million and $1 and $1 million and $2, right? Or coins or whatever. And we see this with infants, right? So infants can tell the difference between 1 and 2 at 6 months, but not between 2 and 3. And they get, at about 10 months, they can tell the difference between 2 and 3, but not between 6 and 7. So this suggests that there might be we might be able to learn how many things there are over time. This isn't innate. This has to develop. Yeah. Okay. Monkeys do this as well. They can discriminate. So the cracker test is cool. Yeah, you put them some crackers in a cup, and then you put 3 in one and 2 in the other, and you see which one they choose. They want the cracker. So if they can tell the difference between 2 and 3, they will choose 3. They don't do so well with anything above 4. So 3 versus 8 or 4 versus 8 is about 50-50. And they can figure out small sums. So this suggests that there might actually be genuinely different processes going on when we're thinking about numbers, small versus large. And again, this is one of those things that kind of seems, it's weird and kind of cool, but you see it in yourself. Like you can't count, like you wouldn't be able to tell the difference between 67 polka dots and 68, but you might between 6 and 10, right? Okay. So particular modules might exist. And these particular modules that we talked about, Machiavellian intelligence and number sense, are different in kind than Fodor's modules, right? Again, Fodor's modules like sight and sound perception of various sorts, color, those still count as modules for evolutionary psychology, but we also have these other more abstract psychological modules, processes. There's arguments from specialized deficits to specialized modules, which we'll go into next. So there has been evidence that we've already seen for particular deficits in perception. Prosopagnosia, the face blindness. There are people that literally cannot tell the difference between each other's faces. I have a friend like this who needs to pay attention to other things, like what clothes you're wearing, what haircut you have, in order to tell people apart, even their own spouse. Evolutionary psychologists take this one step further, and they argue for other modules that might exist. So there's this very famous task in psychology called the false belief task. The basic idea is you sit the toddler in front of a stage where Sally and Anne, Sally puts a ball in a box and takes the ball, or Sally then leaves, Anne takes the ball and takes it from the box and puts it somewhere else. And then Sally comes back in. And if the child understands language, you just ask, where will Sally look for the ball? The idea is that children should know that Sally is a different creature with their own psychology. And if they don't know that, then that means that they don't believe that other creatures could have false beliefs. So the child looking at the screen will know that the ball's not where Sally would think it is. But if they think that Sally has access to that information, it's evidence that they don't actually have a true understanding of other minds. There's evidence for children passing this at 4 years old. Even at 18 months, toddlers will look longer at the empty place when Sally re-enters, the empty box. The idea being, basket in this drawing. The idea being that even toddlers have sort of an idea of what's about to happen. But evolutionary psychologists argue people in the autism spectrum, age 6 to 16, fail this with some regularity. The idea being that there might be some specific false belief module of some sort that autism spectrum reveals could go awry. All right, deficits, modules. Okay, maybe you accept that, maybe you don't. All right. For the next thing, we're going to have to go back and compare these, but I'm just going to stop this here.